Right, so we've graduated now up the complexity of differentiation through chain, product, quotient. We can now differentiate the special function y equals e to the x. And now we're going to look at the inverse of that, which is the natural log. And the way that we differentiate this is quite neat. We don't worry about a power series. What we do is rewrite that with x as the subject. So basically, rather than writing y equals ln x, we're going to write x equals e to the power of y. So basically taking natural exponentials of each side, because the ln and the exponential undo each other. They're inverse operators. Now I can differentiate this, but rather than dy dx, I'm differentiating x with respect to y. And I know that that is e to the y. I also know that just like dealing with fractions, if I've got that, then I can invert these, sorry, not inverse them, to get dy dx is 1 over e to the y. So dy dx is 1 over e to the y, and e to the y is x. So therefore dy dx equals 1 over e to the y, which is x. So when you differentiate the natural log of x, you get 1 over x, which is another function that you need to be able to memorize the differential of. It's not that hard. Where it gets a bit confusing is when you've got knowledge of integration as well and you can't remember which direction you're traveling in, whether you're going from 1 over to ln or the other way around. So that's another tool in our differentiation toolkit now.